In this lesson, you will learn to use a calculator for many different purposes. You will learn how to evaluate logarithms with any given base, as well as solve equations by using logarithms. And when we use our calculator, you're going to learn how to use a calculator with radicals and exponents, with a common logarithm, which is a log with a base of 10, with a natural logarithm, and with a natural exponential. To illustrate how to use a calculator, I'm going to walk you through by using this online calculator on the website desmos.com. And every calculator is a little bit different, so take note of that as we begin. On the left, we see our different examples that we're going to walk through. So first off, we have 0.173 to the 6th power. And so when you're doing this, one of the buttons that you might see on your calculator is this button right here, where it's a to the b power, or it could be x to the y power, and that is going to be your exponent button. So when you type in this problem into the calculator, I have 0.173, and then my exponent button is going to be right here, and then I type in a 6. And we see my solution is going to be 2.6808 times 10 to the negative 5th power. And remember, with scientific notation, as we see here, if you don't want scientific notation, I can move the decimal place 5 places, because your exponent is 5, and move it to the left to make it a smaller number because of the negative. So my solution would be 0.0000268. Now using radicals, we have the 5th root of 493. There are two ways you can do radicals. Remember, you can use radicals the same way that you would with an exponent. And I can convert back and forth between radicals and exponents. So what I could do is I can convert this into an exponent where instead of the 5th root, the 5 would be the denominator of the exponent, and then the 1, which is an assumed 1 with the 493, that's going to be your numerator. So what I have is going to be 493 to the 1/5 power. I can do the same thing where I can type in 493 and then push your exponent button, and then take 1 divided by 5. And then my solution, as we see, would be 3.4559, etc., which can round to be 3.46. Here, if we had a radical, the 6th root of 786, like we said, we could convert into an exponent if we wanted, but the other way is we can instead use the radical button. So don't do the square root button. So don't use this one right here because that is a square root. What I want is going to be this button right here, where many calculators you might need to put your exponent first and then push this button. And actually I need to delete all this. But here on the computer, if I push it, there's a space right there where I can put in your index. So the index is a 6, and then I can click here and type in my radicand, which is 786. And I type it in, my solution is 3.037879, etc. Okay, so either way, we can use the radical button, or you can use exponent button, but either way we get the same solution back out. So right here, for the next example, we have the cube root of 412 squared. So once again, either way, I can use the radical button, or I can convert into exponents. If I use the radical button right here, my index is going to be a 3, and then over here I put in 412, and then the exponent button, and I square it. So my solution, as we see, would be 55 point, and it should be 7265. Wait, no, I did 416. It should be 412. There we go. 55.36876, etc. The other way you could do it is convert into an exponent, where I could have 412, your exponent button, and then the 2 and the 3, your exponent and your index, I can write as the 2/3 power, which would still give me the same solution. Okay, also know how to do logarithms. So here we see the natural log of 25. So to type this one in, there's a natural log button. It's an ln button. And if we push the ln button and then put in the number we want, notice we get our solution, 3.218, etc. And then for the other logarithm, the log 25, for this one, what I want to do is find the log button on your calculator. On the website here, you'd have to go to, I think it was function. Yeah, here we go, log, and push that button, and then type in the number 25. And that's going to be 1.3979, etc. By the way, we notice here for log 25, there's no base written. And that is because your calculator, or I guess a lot of calculators, only do base 10. If you see a button like this where there's no base, then it's an assumed base 10. Many calculators only do base 10, but there have become more and more calculators that are made where we can do other bases as well. But if it's not written, it's an assumed base 10. And then we have here e to the 5th power. So to do that one, there's an e button on your calculator. And it might be a second function above the natural log, or vice versa, where the e is the primary button and then natural log is the secondary. Either way, here on the website we have a button right here where it's e to the x power. So we can push that button and then type in your exponent, which is a 5. So my solution for e to the 5th power would be 148.41, etc. So now we have learned the different laws of logarithms. We have now just learned how to use your calculator, and we can combine to solve any equation where the variable is in the exponent. And to solve where the variable is in the exponent, what we can do is take the logarithm of both sides. So for example, here we have 3 to the 2x power equals 6. And the question is, what is x? Well, what I can do, because the variable is in the exponent, I can take the log of both sides, but remember your calculator many times will only do a base e or a base 10. So what I can do is I can take the log of both sides, just like we can add the same thing to both sides, we can subtract the same thing. We can also take the log, where now I have log base 10 of the left side, and then log base 10 of the right side. And the reason for doing that is because using that third law of logarithms, I can pull the exponent out and bring it to the front, where now I have 2x times log base 10 of 3. And then from here I can solve for x by getting rid of the 2 and the log base 10 of 3. So to do that, I can just simply divide both sides by a 2, which will get that to cancel, and then also by a log base 10 of 3, which will get this to cancel. So I do that over here as well, and I have log base 10 of 6 over 2 times log base 10 of 3. So then I can type this into my calculator, where log base 10 of 6 means that I would push the log button. So log, and the log button on your calculator is an assumed base 10. So I type in log of 6. And that's going to give me 0.7782. And then do 2 times log of 3 on your calculator, and we get 0.9542. And then divide those two numbers to find x equaling 0.8154. Here's another example where we have 2 to the t power equals 10. And once again, we have the variable in the exponent. So to get rid of the variable in the exponent, I need to take the log of both sides. When I do that, I want to use a base 10 because most calculators only do base 10. So what I do is I take log base 10 of both sides, where now I have log base 10 of 2 to the t power equals log base 10 of 10. So then from here I can bring the t out in front, and now I have t times log base 10 of 2 equals log base 10 of 10. And then to solve for t, I can divide both sides by the log base 10 of 2. And what I have is going to be t equals log 10 of 10 over log base 10 of 2. And I could put this into my calculator, where log base 10 of 10 is equal to 1. Log base 10 of 2 is equal to 0.30103. And when I divide, I get t equaling 3.32. Here we have one last example where now the base is an e. And same concept, we have the variable in the exponent. So what I need to do is get rid of the variable in the exponent. And to do that, I can take the log of both sides. Well, when I take the log of both sides, my calculator can do base 10 and base e. And because here I have an e, I'll choose to use a base e when I take the log of both sides. So taking the log base e of both sides, I now have the natural log of e to the 3x equals the natural log of 9. And then using that third law of logarithms, I can bring this 3x out in the front, where now I have 3x times natural log of e equals natural log of 9. Natural log of e, we have a base e, and this is e, so natural log of e would just be 1, because e to the first power gives me e. So I have 3x equals natural log of 9, and then divide both sides by 3. So now I have natural log of 9 over 3. Natural log of 9 is 2.19, and then divide by 3, I'm going to have x equaling 0.732. So as we said, many calculators only can do a base 10 or a base e. But there are times when you need to find the answer with a different base. So what I can do is I can change the base using this formula, where here, let's say we have a log base a of x. And we want to convert the base a into a base b. What I do is I take log base b of this number divided by log base b of this number. So for example, here we have log base 4 of 6, and we want to solve using our calculator. We want to get an actual number answer back out. Well, what I can do is I can change the base to a base 10 so that my calculator can find the solution. So to convert into a base 10, what I do is I take log base 10 of this number and then divide by log base 10 of this number. So log base 10 of 6 over log base 10 of 4. And when I do this, I'm going to get 0.7782 over 0.6021, which would give me 1.292. Here's another example where we have log base 6 of 7. And once again, to convert into a base 10, what I can do is I can take log base 10 of the 7 right here, and then divide by log base 10 of this number, the 6, and then plug that into my calculator. So when I plug this into my calculator, what I have is going to be 0.8451 divided by 0.7782. Which would give me 1.086.